The start of all things. The Big Bang. The idea that the cosmos was suddenly born and is not infinite. Until the mid-20th century, most scientists viewed the universe as ageless and without end. That changed when Einstein's relativity provided a better grasp of gravity, and Edwin Hubble found that galaxies are receding from each other, matching earlier forecasts. In 1964, by pure chance, cosmic background radiation was discovered, a remnant of the infant universe, which alongside other observational data established the Big Bang as the accepted scientific theory. Since then, advanced technology like the Hubble telescope has given us a clear picture of the Big Bang and cosmic structure. Recent data even suggests that the expansion of the universe is picking up speed. But how did this Big Bang function? How can something emerge from nothingness? Let's explore what we know. We can set aside the beginning for now. To start with, the Big Bang was not an explosion. It was space itself stretching out everywhere all at once. The universe began incredibly small and rapidly grew to the size of a football. The universe wasn't expanding into anything. Space was simply expanding into itself. The universe cannot expand into anything because it has no boundaries. By definition, there is no outside the universe. The universe is everything there is. In this scorching, dense state, energy transformed into particles that existed for only the briefest moments of time. From gluons, quark pairs were created, which then annihilated each other, perhaps after releasing even more gluons. These found other fleeting quarks to interact with, forming new quark pairs and gluons again. Matter and energy weren't just equivalent in theory. It was so hot they were essentially the same substance. Somewhere around this point, matter triumphed over antimatter. Today, we are left with almost all matter and nearly no antimatter. Somehow, 1,000,000,001 matter particles were created for every 1,000,000,000 particles of antimatter. Instead of a single massive ultimate force in the cosmos, there were now several refined versions of it acting under different rules. By this stage, the universe has stretched to 1,000,000,000 kilometers in diameter, which results in a drop in temperature. The cycle of quarks being born and converted back into energy abruptly stops. From now on, we work with what we have. Quarks start forming new particles, hadrons, such as protons and neutrons. There are many combinations of quarks that can create various hadrons, but only a few are stable for any length of time. Please take a moment to realize that by now, only 1 second has passed since the start of everything. The universe, now 100 billion kilometers wide, is cool enough to let most neutrons decay into protons and form the first atom, hydrogen. Picture the universe at this stage as an extremely hot soup, 10 billion degrees Celsius, filled with infinite particles and energy. Over the following few minutes, things cooled and settled down very fast. Atoms formed from hadrons and electrons, making for a stable and electrically neutral environment. Some refer to this era as the Dark Age, because no stars existed and the hydrogen gas blocked visible light from moving around. But what is the point of visible light anyway, when nothing living yet existed that could have eyes? When the hydrogen gas clumped together after millions of years and gravity placed it under immense pressure, stars and galaxies began to form. Their radiation broke down the stable hydrogen gas into a plasma that still fills the universe today and allows visible light to pass. Finally, there was light. Okay, but what about the part we didn't discuss? What happened at the beginning? This part can be defined as the Big Bang. We don't know at all what happened here. At this point, our scientific tools fail. Natural laws lose their meaning, and time itself becomes warped and unstable. To understand what happened here, we need a theory that merges Einstein's relativity and quantum mechanics, something many scientists are working on right now. But this leaves us with a lot of unanswered questions. Were there other universes before our own? Is this the first and only universe? What triggered the Big Bang, or did it just happen naturally based on laws we don't yet grasp? We don't know, and maybe we never will. But what we do know is that the universe as we recognize it started here and gave birth to particles, galaxies, stars, the Earth, and you. Since we are ourselves composed of dead stars, we are not separate from the universe. We are part of it. You could even say that we are the universe's way of experiencing itself. So let's keep on experiencing it until there are no more questions left to ask. If this journey through the birth of the cosmos changed how you look at the stars above, please subscribe and like the channel. We are uncovering the vast history that time tried to hide. Let's build our understanding of the future together. The next cosmic mystery will be revealed very soon.